So you remember we started talking about the new topic, quadratic equations. I told you a quadratic equation. Let us review a little bit. What is a quadratic equation? Yes?
Equation which the highest exponent
is 2. Okay? So in general, I told you that this is a quadratic equation equals to 0. So you have a term. This is called the quadratic term because it involves x squared. This is a first degree term, involves x, and this is just a constant. So in general, this is the most general second degree equation, or in another language, quadratic equation. And we want to solve it. We solved it, we considered the special cases. I told you that if b is 0, we did it in Math 1c. So let me give an example. For example, here, if I write x squared minus 4 equals to 0, if you compare this with that equation, a is 1 in this problem because a is the number multiplied by x squared. This number here is 1, even though it is not written. B is the number multiplied by x. There is no x here, so this means that b is 0. And c is the number without any x's at all, and that is minus 4. So when we had this in Math 1c, we didn't talk about that we are solving a quadratic equation systematically because it was so simple, you knew how to solve it. So if b is 0, this is still Math 1c lesson. So if I ask you to solve this, how do you solve it? Use the same method for Math 1c, which is I move 4 to the other side, and then I say x is square root of 4. But because this is even, if you remember from Math 1c, I have to put plus and minus. And sometimes this number is calculatable, its exact value, so I will write plus or minus 2, and these are the solutions. Yes? For example, if I want to give you another example, I can write 2x to the power of 2 plus 5 equals to 0. Again, if I ask you, is this a quadratic equation? You say yes, because the highest power of the unknown is 2. And if I ask you what are a, b, and c, you can immediately answer that. A is the number multiplied by x squared, which is 2. B is the number multiplied by x, which is 0. And c is the number without any x's at all, which is 5. And then again, you see that this is this case. So it means that you don't need to know anything new. Math 1c knowledge is completely enough. So I move this to the other side, and then I divide by 2. But then what happens if I want to find x? I have to find a number or numbers whose second power is minus 1, 5 over 2, and we know it's impossible. Because if I have a number raised to power 2, it is always non-negative. Then it doesn't mean, Babak, the question is wrong, you have to change it. No, you will come to this step and then you write no. I told you yesterday that it is good to write this adjective, no real solutions. Real means the set of real numbers, because there is another set of real numbers called complex numbers. You will study them in Math 4. This equation has solutions if we consider complex numbers, which was one part of this course as well, but it is eliminated, so we don't study that here. So what I expect you to write is to write no solutions, or if you want to write it more complete, you say no real solutions, that's it. But this doesn't mean the question is wrong, no. This is an equation, my goal is to find all solutions, but then I realize there are no solutions, so I answer no solutions. That's not something that you say is wrong. But we also learned something which was Math 2C lesson, but a special case. So I told you that what happens if C is 0? Okay, so let me give you another example of that type. So do you remember what we are supposed to do? For example, I give you this equation. So in these two cases, again, you see, I am talking about the special case B0. Now, let me give you this question. 2x squared minus 5x equals to 0. If I ask you to solve this equation, you immediately realize that this is a quadratic equation. So what we do, if I want to compare it with the original equation, so you see here, if I ask you what a is in this problem, a is 2, because a is the 1 multiplied by the second x squared term. What is b in this problem? What is b? Yes? b is the 1 multiplied by x. In this case is minus 5. And what is c? c is the number without any x's. But there are no numbers without any x's. So c is 0. So you see this is c0. C0 is also very simple. Do you remember what was the method? Yes? You factorize. So you pull x out, it becomes 2x minus 5 equals to 0. And do you remember the rule I mentioned yesterday here? And this is only happens if this number is 0. And that is called what? The zero product rule. What is that rule? That rule tells you that if a bunch of numbers, if the product of a bunch of numbers is equal to 0, at least one of them should be 0. So here I have two numbers. This number, I don't know. This number, I don't know. But I know something. The product is 0. It means that either this one is 0 or 2x minus 5 is 0. This is already the answer. So one possible answer is 0. The other answer is what? I need to solve it. So 2x is 5. It's a first degree equation. I divide by 2, so it becomes 2 comma 5. So that I have two answers. And let me write this with red. I think that was more or less the same example. I told you that one thing that some students make is to move this to the other side and then divide by x. So they divide by x. It seems very reasonable, because if you divide by x, then it becomes 2x is equal to 5, and then x becomes 2 comma 5. It's not wrong, you see. 2 comma 5 is one answer, but this is not a solution. Why? Because solve means find all of them. If you find one of them, not the other one, you haven't completed the solution, so you have to find all of them. So this is why don't do it in that way. It is not totally wrong, but as I told you before, I don't know how many of you remember, I told you why this reasonable solution gives rise not to a complete solution is because when I divide by x, I am not allowed to divide by anything I like. I can divide by something which I know it is not 0. So when I divide by x, implicitly I am assuming that if x is not 0, this is the answer. But then what happens if x is 0? This solution does not work. So don't do it in that way. So today we want to complete the problem. What happens if a, b, c are none of them is 0? Then of course that is the main topic. So you see, if b is 0, Math 1C lesson. If c is 0, method is factorization. Okay, as I told you, I am not factorizing the equation. I am using the method of factorization on the left side to solve my problem. I cannot give you an equation and ask factorize the following equation. This is grammatically wrong. So I have to say, solve the following equation, but you used factorization on the left side to solve your problem. Okay, let us try to solve what happens if none of them is 0. In the near future, we will find a formula for it, and the formula is always in the formula sheet. But just memorizing the formula, you will not understand why this formula works. This is why the book has done it in 2 steps. One step without introducing the formula under the title, the completing a square method that I want to describe today. And then of course, later we will use the same method of completing a square to find the formula once for all. And that formula solves all my problems. So I don't need to have different points of view about how to solve the problems. But still, even though the formula that we will discover later solves this part, that part, that part, but I would recommend you still learn them, because I myself, even though know that formula, when it comes to these kinds of problems, I solve it using this method rather than using the formula, because the formula makes it unnecessarily complicated. Okay? Okay, we will repeat, don't worry. So this I want to describe today. So if someone asks you what we are doing, I am introducing the method of completing the square, okay? Completing the square. Completing the square, this is just one name. Completing the square method. To solve a quadratic equation in its full entirety. So none of them is zero. But of course, I start with a very simple example. So let us try to solve this one. X squared, and then I have plus 6x, and then let me write it as 5, yes, equals to 0. By this example, I am telling you how to do it. These steps are very simple. Just try to learn them. Okay. Here, if I ask you what is this, you will tell me this is a quadratic equation in its full generality. Why? Because if I ask you what A is what? A is the number multiplied by x squared. What is that number?
No, 1.
1. Because if you 0, that's 1. What is B?
6.
6. And what is C?
5.
5. So is the previous methods will work here? No, because neither B is 0 nor C is 0. So we have to use another way. I want to describe what you do here. The first thing that you do is to move 5 to the other side. Okay? X squared plus 6x, and then you move it, it becomes minus 5. Why this is called the completing square method? Because you need to ask yourself, what should I add to both sides so that the left-hand side becomes a complete square, meaning that it becomes the answer to a squaring rule. Yes? So do you remember, this is why sometimes people in the previous exercises you are training to yourself. So you put a box here. So the question is that what should I put in this box so that it becomes the answer of a squaring rule? So what that number is? We had this before. We solved the hard ones. You remember? Some of you also answered that. 9. Do you agree? If I put 9 here, then what happens for this? It becomes x plus 3 to power 2. Why? Because this is x squared. 2 times the first one times the second one, and the second one is squared. So you have to guess this number. Okay, I can tell you how to guess, but because we trained before, I don't want to confuse you. Anyone agrees that 9 is good?
Yes.
So I want to have a 9 here, but I cannot just add 9 to this one, because I want to respect the meaning of equality. If these two are equal, and if I add 9 to it, to keep equality, I have to do what? 9 to the other side. So we can write minus 5 plus 9. Okay? And then what happens? This becomes a complete square now. So this becomes x plus 3 to power 2. What happens there? 4. But then it becomes Math 1C lesson now. Yes? X plus 3, I don't know what that is, but I know square is 4. So what is x plus 3? Is two numbers, not one number. So you see, I don't know what this is, but I don't know. I know this question mark squared is 4. So there are two options. Either the question mark is 2, or everyone minus 2. Okay? If this is the case, I move 3 to the other side because now this is a first degree equation. It's a primary school task. So it becomes x equals to 2 minus 3 with minus 1. And then this one, I move this to the other side. X is equal to minus 2 minus 3, which is minus 5. So the answers to this equation is minus 1 and minus 5. So this is the method of complete square, and it's very, very simple. So it is not something new. So the only thing that you have to remember is to move if B is 0, that method. If C is 0, this method. If neither of them is 0, this method. Of course, this becomes a little bit more complicated if I have also a number here. Not complicated, guessing becomes a little bit harder. But it is not a big deal. I mean, if you understand what you are doing, you can immediately guess. And of course, I will not give you big numbers if you are not allowed to use calculators. You want to understand the topic. So let us review. If someone tells me, Babak, what did you find? What should I answer? Yes?
Roots.
The roots. Meaning what? Okay, no, meaning, I mean, I'm just asking what is the meaning of a root. A root is a number that if you replace x with that number, it works. And then it shows me how many numbers there are there to work. 2. One of them is minus 1, the other one is minus 5, and there are no more. Is that right? Okay, so let us practice this a little bit. Method of completing this square. Okay, so let us try to give you more examples. I can use some examples in the book as well. They're making very big numbers. We don't have to make very big numbers. Okay, so let us do this. I want to wait for you. I want to see if you understand that. We don't, because this is not complicated. If you understand it, why should we spend so much time on doing this? So this question is from the book. It is x squared plus 12x minus 13 equals to 0. Yes, so I want to wait for you. Just follow what I told you. Try to remember what I told you, then do it. It will go to your memory. What is the question? If I want to give it in exam, of course I just don't drop it on the paper. What do I write for it? Solve the following equation. The word solve. Yes? If you just listen, passing is guaranteed. It's not a very strange thing to pass. So Ahmed is asking if A is 0, what happens? So in principle, when I introduce if A is 0, it means x squared is gone. And this is not a new lesson anymore because that is a primary school task. So that's a good question, I should have mentioned that. When I write a quadratic equation, I always mean that A is not 0 because if A is 0, there is nothing new to it, yes? Okay. So I think it is simple now, yes? What is the first step? So that is like an algorithm, and there is nothing that can surprise you here. You always follow the same steps. First, you realize this is a quadratic equation. You ask yourself, is B 0? You go to the method of 1C, let's say. If C is 0, you go to factorization method using the zero product rule. If none of them is 0, you follow this. What is the first step in following the completing a square method? Is to move 13 to the other side. That's very simple. Okay, then you ask yourself what I need to add to the left side to make it a complete square. By making it a complete square, I mean to find a number so that when you add it, it becomes the answer to a squaring rule. What that number is? What that number is?
36.
36. Could you come up with a 36 yourself? If you're not, I can give you a rule of thumb. I don't want you to memorize that. The rule is to divide this number by 2 and square it. Okay? I didn't want to tell you before, I just want you to use your brain. But if you get stuck, this is the rule of thumb. 12 divided by 2 in your head is what? 6, and then square it is 36. So that is your number. Okay? So you add 36 to both sides. Yes? So what happens? It becomes x squared plus 12x plus 36. But I want to respect equality. So when I add 36 here, I have to also add 36 there. But then you know what the answer is. The answer is definitely a complete square. What is that? X plus 6. And then on the right hand side I have 49. Here you have to be careful. There are two scenarios. If I ask you what is x plus 6, you say x plus 6 is a number whose square is 49. So what are those numbers? There are two possibilities. Either or minus 7. If this is 7, x is what? 1. If this one is minus 7, x is minus 13. These are the numbers. Yes, is that right? So if you can do it in your head, just do it. Otherwise, if you get stuck, divide this number by 2 and square it. And that is your number that you have to add. Okay. But now let me give you another example. It's a little bit more tricky, but this is not hard. Now, these two examples, you see, when I gave you, this is the simple version. The simple version is the version that a is 1. You see, in my example, I solved a was 1. If I ask you what is a in this problem, what is your answer? Is 1 again. What is b? 12. And what is c? Negative 13. So in those two examples, one I solved, one you solved, both of them are a is equal to 1. Now let me give you an example which becomes a little bit more complicated if a is not 1, but not that hard. So let me give you an example here. So the example is 4x squared the same title, solve the following equation, 4x. And then what do you do? And then you have minus 15 equals to 0. So if I ask you what a, b, and c are in this problem, you will tell me that a is 4, b is again 4, but c is minus 15. So none of them is 0, so I have to use the completing square method. And a is not 1. So there is one step more to the algorithm. So the first thing that you do is, as before, you move 15 to the right. So it becomes 4x squared plus 4x is equal to 50. The next step is to divide everything by this number, which is something more than this one, of course. So here, the first step is to move the constant number to the right as before. But before completing the square, you divide everything by this number, if it is not 1. When I divide this by 4, so this is division by 4. This means it becomes x squared, but when you divide by 4, you have to divide everything by 4. So this becomes also x, but then that becomes 15 over 4. And try to keep the fractions. Of course, in this case, this fraction is exact. You can write the exact decimal numbers, but let us work with fractions. Okay, the same scenarios.
Is this only if A, B are the same?
No. If a is not 1, regardless of if it is equal to b or not. Okay, but this is the same problem, but you have to complete this square. This is not a simple number like this. It is good to know the rule of thumb. What was that? My question is still the same. I want to write something here and there. so that the left-hand side becomes the answer to a squaring rule. If you can do it in your head, just do it. If not, I told you the rule of thumb. What was that? Take this number, which is 1, divide it by 2, and square it. What is the answer? 1 over, you're multiplying by 2. This is power 2, yes? 1 over 2 to the power of 2 is 1 over 4. Why? Because 1 over 2 to power 2 means 1 over 2 multiplied by 1 over 2. So 1 times 1, 2 times 2. Yes? So your number is 1 over 4. So you have to add 1 over 4 to both sides. Yes? That's it. But now can you tell me, is this the answer to a squaring rule? If you haven't done wrong calculations, make sure this is the squaring rule. What is that? X plus 1/2 to the power of 2. Why? Because the first one is squared. That's correct. 2 times the first one times the second one. These 2 and that 2 are cancelled, so it becomes x. That's also correct. The second one is squared. That's also correct. But what can happen to the right-hand side? 15 plus 1 is 16 over 4, which has a very simple name. What is that? 4. But then again, the rest of the story, you know what to do. You have a number whose squared is 4. So how many options are available? 2. Either x plus 1 over 2 is what? 2, or x plus 1 over 2 is minus 1 over 2. Oh, sorry, minus 2. Okay, I need to find x. So I move 2 to the other side. It becomes 2 minus 1 over 2. I hope that you can do these kinds of calculations. It is 4 minus 1, 3/2. This is one answer. I moved 1/2 to the other side. It's minus 2 minus 1/2. I don't know how many of you can calculate this, can you? Minus 2 minus 1/2, what's the answer? Minus 5. If you don't, please let me know so that I explain. But these are simple calculations, yes? I have to change the battery. I will write a question for you and wait for you. So you see, the complication is because I have to deal with fractions. This is not complicated, okay? So if this number is not 1, just then the step is to divide by that number. Any questions? Okay, I will write one. It's a little bit harder than the one that I solved, but I think you can manage it, okay? There is nothing mysterious here. This is an algorithm. There is no need to think. You have to follow step by step the algorithm that I mentioned. So I will write one and wait for you. Okay, so the question is, solve this equation. 9x squared plus 6x minus 35 equals to 0. Plain. You know what algorithm is? Algorithm means that you have to respect the order in which you are following. You cannot interchange the order in which I told you. I am not telling that you have to follow my algorithm, because when I am teaching, I have to teach the method that works most of the time. But if you are creative, might be you can find a shortcut. Let's do that if you can. So let me follow the algorithm again. Let me review everything. The people who didn't listen to me now. Hello? Listen to me. So the first thing this is a quadratic equation, and then you need to know A is 9, B is 6, C is minus 35, yes? And then you see that B is not 0, so it is not Math 1C equation. C is not 0, so factorization does not work. So far we have learned one more method, and that is the completing the square method. So what I do in the completing the square method, the first step is to move the constant number to the right side.
Yes.
Okay, so it becomes 9x squared plus 6x, and it becomes 35. The next step is to divide by 9. Okay? So if you divide by 9, it is not hard. You don't have to divide really manually. You just write them as fractions. If I divide this by 9, I have to divide by this number, whatever it is. When I divide by 9, this becomes x squared. Yes? This becomes 6 over 9. It's not hard, but you don't have to write it 6 over 9 because it can be simplified a little bit more. 2 over 3. So you just divide this by 9, it becomes 2 over 3. But if you divide the left-hand side by 9 and you want to respect the meaning of equality, you have to divide this by 9 as well. So this becomes 35 over 9. So which part was hard? I'm just following the algorithm. The hard part is this number, if you call it hard. Yes? Yes? Then you have to visualize. If you can visualize it, do it. Otherwise, I gave you the rule of thumb. The reason that you cannot manage it because you are weak and still in calculating with fractions as simple as these fractions. They are not complicated fractions. So what was the rule of thumb? Can you just divide by 2 and square the result? Okay, if you cannot divide this by 2, then that is not this problem of this lesson. It's a previous problem that you haven't solved yet. So if I divide this by 2, what's the answer? What is the answer? So you see, if you have problems by dividing this by 2, that is on you, not me. What can I do? You don't know how to divide 2/3 by 2. If you want, of course I can teach you again. You divide this by 2. Do you remember the rule of division for fractions? You write the first one, make this multiplication, and flip the second one, which is, and then these 2 and that 2 are simplified, so the answer is 1/3. But it should be at a matter of milliseconds for you to understand this divided by 2 is 1/3.
Can't you just think the 2 on the 2 above it?
Yes, it can. That's the way I do. But anyway, I need results here. I don't care how you do it because that's not a complicated thing. Okay, so this number is this number divided by 2. But I have to do one more thing in a scratch paper. What is that? Square it. What is the square? 1 over 9. Why? Because the square means 1 over 3 minus multiplied by 1 over 2 is 1 over 9. So I realized that I have to add what? I have to add 1 over 9 to the left, but I want to respect the equality, so I have to add the same number to the right as well. Okay? This one, if you have done your calculations correctly, don't even doubt about it. It becomes a complete square by this algorithm. So what that thing is here, x, the sign is positive, the other one is 1 over 3. Yes? Is that right or not? The first one is squared, 2 times the first one, times the second one, but 2 times 1/3 becomes 2/3, and x is x, and the second one is squared as well. Yes? And then can I do something there? 30, because I am fortunate that the denominators are the same, so I write the same denominator, and then I add the exponents, the numerators become 36. Yes? And then I am lucky. Can I simplify this?
Yes.
Yes, it becomes 4. And then here, again, algorithm, there is nothing to think. Something to power 2, a number to power 2 is 4. I have 2 options. Either that number is 2, or x plus 1/3 is minus 2. Yes? And then from here, what is x? Is 2 minus 1/3, which is 5 over 3. Do you know how to do them?
Yes.
So you see, 2 minus 1 over 3. Instead of 2, I write 6 over 3. My goal is to make the denominators the same. Then I can put the same denominator and subtract them. It becomes 5. But I would expect you to be able to do it in your head immediately, yes? Okay, here what happens? X is equal to, I move minus a third there. 2 minus 2 minus a third. But you don't need to be in a hurry, okay? So if you don't do it in your head, you go to a scratch paper, minus 2 minus a third. I do the same thing. Instead of minus 2, I write minus 6 over 3, and then I have minus 1 over 3. So the answer becomes minus 6 minus 1. So it becomes minus 7 over 3. So what happens here? It becomes minus 7 over 3. So two answers. 5 over 3 minus 7 over 3.
Baba, isn't it easier to use the completing square right away instead of doing fractions?
Yeah, if you can do it, but it is not possible here. I want to make sure that you understand what's going on. If you want to do the completed square method, what do you do exactly? So what I'm saying, if what you do on the math paper is correct, you get the full points. It doesn't mean that you have to follow me. It's better not to follow me if you cannot. If you can not follow me and find the correct answer, it means that you are understanding yourself. But be careful. What do you say that? You are saying that can I do it directly? How?
Plus 1.
Plus 1.
Yes.
So you write 9x squared plus 6 plus 1. It's very good that you told me. And it is much simpler in this way. Okay? But I cannot guarantee this to you. When I am teaching here as a teacher, in principle, I should teach in a way that always works. Okay? I don't want to kill your creativity. So if you are creative to see that why should I go through this mess, of course this is much simpler. Yes? He added 1 unit because he had a better vision. Because he realized my goal is what? To complete a square. Who cares how? What I am describing is one method that always guarantees completing a square method. You understand what I mean?
Yes.
Okay. So now, why 1 works? It's much faster to do it in this way. What's the answer?
3x plus 1.
Okay, but you have to have practice before so that you can recognize the pattern much simpler. And I think, Bino, that is what you wanted to do. Okay? So that is the number. So this becomes 3x plus 1. Do you agree?
Yes.
Double check. Why? The first one squared. 2 times the first one times the second one squared. Much faster. Okay? But this, I hope that you agree with me, I cannot teach you this method. Because this changes from one problem to a problem. Okay? I cannot teach you a general idea that works every time. But if you are creative, of course, you can do things efficiently. And that's the whole point. Okay? So this becomes 36. And then again, the same story. I have a number to power 2 is 36. What's that number? There are 2 possibilities. One is 6 or minus 6. And then you see that how much this one is faster because you don't even care about fractions. Yes? So here you just move it to the right side. It becomes what? 5. But you want x, you divide by 3. And you don't have to work with it because that's finished. Is that answer? Yes? And then here you move this to the other side. Becomes minus 7. And then x becomes what? Minus 7 over 3. Of course, that is exactly, this is very good that you told me, because whenever you are creative, of course you can do problems more efficiently. But I cannot teach you creativity. We can practice together in hard problems about to improve our creativity. But there is nothing I can teach, because if I could teach you, I could have taught myself. Then I could have solved all my problems. Okay? So, but this is much better. So don't close your brain. If you find a shortcut, please do that. And I will not tell you that why didn't you follow my rules, so this is 0. No. That's the good point of mathematics, yes? But the method that I told you here, for example, if you want to write a code in Python language, might be you'll learn next year, to solve a quadratic equation, you cannot rely that the computer understands your this creativity language, because this is a case-by-case problem. But you can write this as an algorithm. Do this, do that, do this, and then you have the solution. Okay? Is that clear? Okay. I don't know how many of you still feel that you don't know what is going on. Okay, so that's good. So let me give you another example, and then I wait for you to solve it, okay? Okay, so I will increase, so I will go back to the case that this one is 1, but my idea is something else. So let me write this, x squared plus, let me put even number first, so it's simpler for you. 8x, and then I would write it as minus, so plus 2. So let me write it as minus 2 equals to 0. Yes, I want to wait for it. Brought this example. The only reason that I brought this example because the answers are not friendly as before. Yes, you have to live with the square root sign. Could you find the answer?
Yes.
Don't think that the answer is some very simple number. It involves the square roots. And then it doesn't matter. You'll just put it there. You even don't need to calculate it. Okay, so let me review. Again, let us review together. What is the first step? Why do I use the completing a square method? Because b is not 0, c is not 0. If b is 0, the first step, the first method, if b, c is 0, factorization step. But now here, I move this to the other side. This, everything is simple. And this is not the hard ones because this one is automatically 1 here. It's already 1. So what you need to do is to add a correct number. But this is very simple because the rule of thumb will always work in the best possible way. Divide this by 2 in your head, 4, square it, 16. Don't say 8. Square is different from multiplication, yes? So you have to add what? 16. So I add 16 to the left, and I also have to add 16 to the right. But then this is, you shouldn't doubt about it. This becomes a completed square. What a completed square of what? X plus 4. This one becomes 18. But then I have to take the square root, yes? So it becomes x plus 4 is what? 2 numbers. Either square root of 18, don't bother. There is not a number, keep it like this. Or x plus 4 is minus the square root of 18. But I'm looking for x. So I move 4 to the other side. It becomes minus 4 plus square root of 18. This is one answer. If I didn't say anything, I want you to write this answer. If you just put it in the calculator, then you will lose points.
Can you write minus 4 minus square root of 18?
The next one. The next one is minus 4 minus the square root of 18. That's it. But sometimes I say, okay, write the answer to 1 decimal point. Then in that exam, I will provide you with a calculator that you can calculate. But if not, just that's it, and that is better. This exact number.
Baba, you know, with the minus 4 plus, can you write that as square root of 18?
Minus 4, yes. If you like, you can write square root of 18 minus 4.
Does that work?
Yes, that's the same thing, because square root of 18 positive, positive, minus 4 negative, negative. That's the same thing. Yes? So I think your weakness is to find this number. So let us try to do some exercises only on that part of the algorithm. Okay? So I will write a bunch of expressions containing the first two and put a box, fill up that box, yes, fill up that box in a way. My point is that let us try to fix this weakness. Of course, for these cases, there is no weakness. You divide this by 2 squared. Okay? But let me try to review that exercise we did before. I remember we solved hard ones and you did one. Okay? So let us try to fix this one. So what I want you to do is to fill up these boxes so that it becomes the complete square, a complete square. So let me start with simple ones. Okay? So x squared plus 4x plus a box. Then I would write x squared minus 6x plus a box. Then I would say that x squared plus 7x plus a box. Then I can write x squared plus 3 over 2x plus a box. Then let us write this one. 4x squared plus 4x. Let me write this one minus plus a box. And then we can write 3x squared plus 5x plus a box. Yes? If this turns out to be comfortable for you, so you can ignore that algorithm and then you just follow your instincts here. But let me see how it works. Can you fill up all them? So the goal is to put something here so that these expressions in total is the answer to one of the squaring rules. This is the reason. If you feel comfortable with filling up this, you don't need to follow my algorithm. So you can just add that number as you calculated here, and then you can do it faster. Okay, so let us hear from you. What do you put there? 4. Yes. If you are not comfortable, please ask me. Oh, I changed that. What happened? So let me change it. So what is 4? I put 4 here. Yes, is that understandable?
Yes.
Okay, let us practice a little bit more. So what is the answer then if I put 4? What? It becomes what?
X.
I didn't want you to do this part, but let us practice a little bit more. What should I write? X plus 2. Yes? But what can I put here?
9.
These are easy. The rule of thumb works. Divide this by 2, square it. Divide this by 2, square it. It's 9. What will be the answer then?
X
Minus, because this is minus 3. Yes, to the power of. What about this one?
12.25.
Yes.
49?
12.25.
Yes.
Okay, so how did you do that?
Divide 7 by 2, which is 3.5.
Yes,
And then
square it. But you don't have to work with decimals if that's not comfortable. Yes, you can just write this to the power of 2, which is what? 49 over 4. Yes? So 49 over 4 is the answer. Okay, and then in that case, what will be the solution then? What should I write here? X plus, because this is plus,
3.5.
3.5 or 7 over. Yes? Okay, what about this one?
9 over 16.
9
Over 6.
16. Yes? Because you divide this by 2. If you divide this by 2, it becomes 3 over 2 multiplied by 1 over 2, which becomes 3/4. And then you square it. So it becomes 9 over 16. And what will be the form at the end? It becomes x plus what? 3 over 4 to the power of 2. What about this one?
1.
Just 1. Do you agree?
Yeah.
Because if I put 1 here, what will be the answer? 2x minus 1 to power 2. Yes? This is the hardest one probably, which is of course not hard that much. So what is the box here? Anyone could guess this one? Yes, Ismail?
It's the first one.
No, here. What should I put here? Okay, that's what I'm saying. I mean, you can do like this. Think a little bit. If guessing is easy for you, follow your guessing. But if you get stuck, follow the algorithm. The algorithm will always work, but of course it will be a little bit lengthier. Anyone could guess this one? Yes, Ismail?
8.3.
No, I want exact values. Be careful. Even if that is a close guess, that's not good. Yes?
25 over 4.
I don't know. I have to calculate, but I will write your answer here. 25 over 4. Yes? If your answer is correct, let us assume that this answer is correct. Then it should be equal to what? Tell me.
5x plus 5 over 2.
So 5x, what?
8, oh no, I mean
1.5.
1 point.
5.
So it doesn't work, you see? It's not that easy. Even I cannot guess. I don't know how did you guess. So that's why I'm saying that this was intentional. I wrote it here. Because I want to tell you that sometimes algorithm is inevitable. We have to use it. Of course, you can try to engineer it in a way by spending, for example, 10 minutes for this, but you can follow the algorithm, which gives you a faster way to do it. Okay? So that's why I'm saying that algorithm is necessary. So by the way, this is a little bit a strange number, because this one is not a complete square. You know that you have to write something here who's a square. I will solve it, but if you don't like it, just ignore it, okay? So let me just write 3x squared plus 5x, and then plus a box. Okay, if this is going to work, what should I write here? I have to write something whose square is this one.
1.5. No.
No, what is that exact value?
Square root of 3.
X. Square root of 3, x. Yes, this becomes the first one squared, which is this one. And then the other one, I have to write something here so that 2 times the first one times the second one becomes this. So it means that 2 times this one times that one should become the middle one. Yes? Okay, x is the same x. So what should be the question mark? The question mark, which was not easy to guess, is 5 divided by 2 square root of 3. So this number is what? 5 over 2 square root of 3. And then, that was not the question. I want you to do this. Can you tell me what that is?
10 over 2 square root.
No, not 10. 5 to power 2. 5 to power 2 is not 10. Is 25 over what? 4 times 3, 12. So Lennon was very close, but you missed that one. Yes? So this is the answer, which was not easy. Even I couldn't guess. So sometimes algorithms are inevitable. It's better to use them. Okay? But sometimes if we can guess, don't follow my words. Okay? You can just be creative and guess. Yes?
Why doesn't the rule of thumb work? Because it's 25.
No, the rule of thumb does not work because this is not 1. The rule of thumb is only working for the case that this is 1, for the simple case. Yes? And that is exactly why, if this is not 1, we divide to make it 1 so that we can use the rule of thumb. Do you understand? That's exactly the hard part. But this was hard one. You don't have to guess. This I just told you here because I want you to see sometimes guessing is not easy. So this is why we have to have an algorithm. Okay, so that we can, if we cannot guess, it doesn't mean we shouldn't solve the problem. We still want to solve the problem. Okay, any questions? Thank you very much. Lesson is not finished. We have to spend some time understanding the square method, but you remember that next Friday we will have a second quiz, which doesn't cover the first part directly. It will focus on these topics, but might be you get 1 or 2 questions from the previous topic as well. Yes?
Is this E-level for this topic?
No, E-level ones are the simple ones.
Okay.
Yes.
So the more...
And by the way, don't be worried about this, because when we learn this, I don't know, in 2 weeks or 1 week, we will find a formula and use the formula all the time. So the method of completing a square will become obsolete. Why we are teaching it? Because the formula that I want to find it goes through these steps. I can, of course, write the formula and say that don't ask me why this works, it works, and if you're happy. Some people are happy with that. I'm not. I am happy that if you learn what I'm doing, okay? But in the future, for example, for the main exam, I might give you some questions solving the square root, but most of the time you use the formula. Thank you.